In this tutorial, you will learn how to write equations of perpendicular lines. Let's get started. Take a look at this graph and the two accompanying equations on the left-hand side. Jot down some notes about anything you notice and maybe anything you wonder. Pause the video now. All right, what were some of your observations? I know sometimes students say, oh, I observe that the red line has a positive slope and the blue line has a negative slope. And sometimes I see students say that, oh, the red equation has a positive y-intercept and the blue equation has a negative y-intercept. And all of these are really great observations. But what I'm trying to kind of get you to see is there anything similar about what you see on the screen? So I know that I have a lot of opposites, like one is uphill and one is downhill, right? One has positive slope, one has negative slope. All right, so that's something very specific. But how about the equations? Anything there? Take a look at my observations here. The graphs are perpendicular. The word perpendicular means to intersect at a perfect 90-degree angle. See that? All the way around. In addition, although my equations have a lot of different values, what do you notice about their slope values? Are they completely random? Do they have some similarities? Right? So they both use the digits 2 and 3, but they have the digits in different positions. So we call those reciprocals. And that's really important when you're talking about perpendicular lines. Another thing that's really important is that they have to have opposite signs, right? You can't intersect at a perfect 90-degree angle unless one line is uphill and the other line is downhill. So you have to have one positive slope and one negative slope. All right, let's get started with the lesson. The main idea today is that perpendicular lines have opposite and reciprocal slopes. Remember, opposite means one positive and one negative, and reciprocal means that you would have a fraction, or if you didn't have a fraction and you had a whole number, you could put a 1 underneath, and if you flip them over, right, it would be like reversed. So the word reciprocal really means that when you multiply them together, like 2 times 1/2, even though that's a negative 1/2, right? If you multiply them together, the result will always be a 1. The result will always be a 1. So we're going to get negative 2 over 2. Now, having a 1 value is reciprocal. Having a negative 1 value, that's what makes it opposite reciprocals. So again, the main idea today is that the slopes of perpendicular lines have opposite signs and reciprocal values. If I gave you a picture, it might look like they intersect at a 90-degree angle, but how can you be perfectly sure? Right? If you weren't going to bust out a protractor, then you'd have to use their slopes. So you would need some information. You would either need the equation of the line, or you would need 2 points on that line so you could calculate that slope. So by the end of this lesson today, you should be able to say that you can write equations for lines that are perpendicular to an equation or to a pair of points that I give you. And in order to be successful, you have to know that perpendicular lines have opposite reciprocal slopes. In addition, you have to be familiar with the point-slope formula. We'll be using that again today in this lesson. All right, remember the main idea? I've said it about 5 times now. Can you choose the equation of the line that is perpendicular to y equals 2x minus 7? All right, do you think you have your choice? Did you remember the main idea? Opposite, reciprocal. So again, not interested in the y-intercept at all. Only interested in the slope value. So I need something that's opposite, so I need a negative. And I need something that is a reciprocal. So that's going to be the flip of 2, which would be 1/2. So negative 1/2 x plus 6. Let's try this again. Choose the equation of the line that is perpendicular to y equals 5x minus 3. Did you find it? It needs to be a negative, and it needs to be a 1/5. So that's also choice letter B. At the previous lesson on parallel lines, I suggested that you pause the video and take down some notes. This is what I had you write. Today I think it would be a good idea to add this information to that notes page. So go ahead, pause the video, and write down this information. No, seriously, I mean it. I know you think you're going to remember it forever, but trust me, in a few months from now, you're probably going to forget. You need to have something to go back to so you can look up the information. All right, now that you've paused the video and you've written it all down, let's take a look at a question. Determine if these two line segments are perpendicular. So what we have here are two slopes. So what I'm going to do is I'm going to calculate, what we have here are two sets of points. So what I'm going to do is calculate the slope of segment QR. Remember, you're going to use your slope formula to do that. So you should have this memorized by now. All right, start by setting up my subtraction fraction and doing y minus y and x minus x. It gives me the value of 2/5. And now I'm ready to find the slope for segment ST. Again, set up your subtraction fraction, y minus y and x minus x. Looks like I'm going to get -5/2. So here are my slopes. Are they opposite signs? Yes. Are they reciprocal fractions? Yes. So this is a set of perpendicular lines. All right, let's try that again. Are AB and CD perpendicular to each other? So let's find the slope of AB. Segment AB would be 6 minus 8, y2 minus y1, x2 minus x1. And don't forget, if you ever have a minus and a negative or two signs in a row like this, you can make that one large positive sign. 6 minus 8 is -2, and 2 plus 1 is 3. So the slope of AB is 2/3. And the slope of CD is going to be 3 minus 2 over 3 minus -1. It's going to be 1/4. Well, these two segments do have opposite signs, but they are definitely not reciprocals. So therefore, these two segments are not perpendicular. You saw that symbol I wrote there? Looks like an upside down capital T. That's the math symbol for a perpendicular intersection. So these two segments are not perpendicular. All right, I think you're starting to get the hang of this. Okay, pause the video now and give these two a try. All right, let's see how you did. How'd you do? The first one was yes, but the second one was no. Now, they're not totally different, right? They're actually exactly the same. Do you remember what that means? So anytime you have slopes that are exactly the same, they definitely don't intersect because they're parallel. Now let me go back for a second here. Remember how we said these two lines were not perpendicular? That's because they had totally random slopes, and they had no connection. They weren't opposite reciprocals, and they weren't exactly the same. So these lines actually do intersect. They just don't intersect at a 90-degree angle. Maybe they intersect at an angle more like this. Right? They're not perpendicular and they're not parallel. So that's another combination you can have. All right. Now let's try the task of writing our own equations. So if I want you to write an equation that is perpendicular to an equation that I already give you, you would have to write an equation that has an opposite and reciprocal slope to what you're given. If I also tell you that it has to pass through a specific point, then you can't just willy-nilly make up your own y-intercept. You'd actually have to do some math. Now look at the difference between question 1 and question 2. Question 2 is written in standard form. And when an equation is written in standard form, you actually have no idea what the slope is. So we're going to have to do some work before we can even begin question number 2. All right, let's make some room and get started with example number 1. So first things first, let's take some notes. These are the important pieces of information we need for our point slope formula. Now, the x and y points are pretty obvious, and so is the slope. But if I want a perpendicular slope, I have to change the sign and flip the fraction, right? Opposite reciprocals. And now I'm ready to use my point slope formula. Do you remember this from the other day? Now it has a lot of variables in it, but only a few of them are permanent, right? That's these here. All of those symbols are permanent. Everything else needs to be substituted with our notes. So don't forget, you don't put them in anywhere you'd like. You have to specifically put in the y1 in this first position, then the slope, then the x1. So y1 goes here, slope goes here, and x1 goes there. Don't forget, if you have two minuses in a row, make it one giant positive sign. So y plus 3 equals negative 4/3, and don't forget to distribute here. Use a calculator if you need to. Negative 4 times minus 3 is positive 12. Positive 12 divided by 3 is 4. Use a little subtraction property of equality. And, oops, I forgot my letter x. And voila! There's the equation of the line that's perpendicular to 3/4 x plus 5 and passes through the point of 3, negative 3. All right, if you need another moment, pause the video and look it over. Otherwise, I'm going to move on to question 2. Now, this one's a little more challenging, right? Because we can take some notes over here, but we can't fill them all in because we don't know what the slope is. So we can't take the opposite reciprocal. So I'm going to do a little manipulating over here. I'm going to move this sentence parts around until I get it in slope-intercept form. And that means that my y has to be by itself. Well, I'm going to be a little lazy here and just write one large division bar. Alright, looks like my slope is going to be negative 2/10 x plus 2, also known as negative 1/5 x plus 2. Right? Wow, I just did a lot of work, and that's not even part of my answer. This is just helping me to figure out the notes I need for my new perpendicular slope. Again, opposite, reciprocal, 5/1. Oh, that's not so bad. Now I'm going to use my point slope formula. Those are my permanent skeleton pieces. And now to fill in the correct values. All right. Y minus 3 equals 5x minus 10. Add 3 to both sides. And the perpendicular equation is going to be 5x minus 7. All right, were you able to follow that? I know it moved along a little bit fast. Here's another example for you to look at, just in case you wanted to see a little bit more. So this one was also given in standard form. Now, they didn't show you the work, but they did rearrange it, just like I did in the last problem. And after they rearranged it, they noted that what the new slope is and what the opposite reciprocal would be. And then they filled in all their information. All right, if you feel like you've gotten enough exposure, try giving these 2 questions a try on your own. Pause the video now. All right, let's see how you did. Fantastic. Well, that concludes our lesson on how to write equations for lines that are perpendicular to a given equation.